Yes, hello everyone, and welcome to our first ever feature-length keynote presentation by Dr. Sarah Cooley, the Director of Climate Science at Ocean Conservancy. Hello, Sarah. Thank you very much for joining us. How are you feeling after the technological glitches? Is your adrenaline rushing, or are you okay?
I'm feeling okay now. I just need to not mess with the system anymore. So I'll try to keep my hands to myself.
We're very grateful that you joined us. So it's not very often I get the chance personally to speak with, one of the lead authors of the IPCC assessment reports. And I was just, before we began, I was just curious what it's like bringing all that information together, trying to collate all that information from different scientists all under one roof, knowing that pretty much the whole entire world is watching. I was just wondering if you could share some of your thoughts, experiences, frustrations, or what you feel about the whole process.
Just to clarify, so I am the coordinating lead author for the Working Group 2 report that's in review right now by governments. So our chapter was the oceans and coastal systems and the services they provide. And it is a tremendous job. You look at the list of references and you think, yeah, that's a big job. But every single one of those references has been scrutinized so thoroughly, because we have to actually read the papers. We can't just like name check the papers.
Can't just skim the abstract, but that'll do.
No, you really can't. You have to dig in. And when we're developing assessment statements, confidence statements saying like high confidence or, it is likely that, you have to go through and look at how they arrived at their conclusions in the paper. And then you have to, bring together the 3 or 4 or 5, 10 papers that talk about that. And they all use different ways to get to the conclusion. And so you have to kind of bring all that stuff together. And it's just like a synthesis of synthesis activities like no other. It's really, really amazing how it works. Just in terms of like, you also have to write the report that the evidence allows you to. And I mean, that sounds kind of like a stupid comment, duh, of course. But, we had so many instances where we thought okay, this paragraph is going to be about, some element, right? Some process. And it turns out that what you thought you could say is actually not what you can actually say based on what the evidence actually is.
Interesting.
And so instead of making a comment about, spring bloom times in the North Atlantic basin, you might be talking about succession of plankton species, because that's really what the evidence is about, rather than the bloom, overall bloom time. And just writing about that, it's like this constantly evolving situation, and it's just such a mind-bending experience.
I can imagine. I like the synthesis of syntheses.
Right.
That's a good tongue twister. And another thing I struggle with sometimes is the feeling that personally, there's nothing I can do to help this climate change thing. And sometimes I do feel like, I just get caught up in it and that, we're heading straight for the apocalypse. I was wondering, do you ever feel lost? Do you feel optimistic about the future? Do you feel pessimistic? Like, do you wave between a bunch of feelings?
It varies day by day. Just this morning I was looking at Twitter, and there's a lot of people getting excited and jaded about COP. And, and I think that was sort of like the depth of despair, right? Because there's so many people going, I don't have high hopes. So I had to put that aside. And my feelings vary day by day, right? I mean, in doing this IPCC report, like, we're looking into the belly of the beast, right? We know exactly what the evidence says, and there is a lot of really grim evidence out there. But I think one thing that gave me a lot of hope personally was the fact that because we were also charged to dig into the solution set as part of this working group report. A big piece of what this report is supposed to cover is like, what solutions have been forwarded, how far underway are they, and how successful are they? And so what we are seeing emerge from successful adaptation activities around the world is a a new way of engaging people and working on solutions collectively and collaboratively in a way that hasn't happened before. So I think like the evidence supports that being inclusive and thinking about all the outcomes is actually the right and most robust way to go. So I think that really gives me hope. It just means it's really hard to engage everyone and really include people to the level that is needed to come up with successful solutions. But I think the fact that so many people are working on this and the momentum is for like a greater and greater, more inclusive solution set. And that's what's really working. I feel like it's sort of a positive feedback of good outcomes.
That's pretty much what Al Gore was giving a presentation the other week, and he said pretty much the same thing. So it does seem like we are heading in the general right direction, that things are gaining momentum, and there is some optimism. Okay, so without further ado, if you're willing to go for it, yeah, everyone, just if you can mute your microphones, turn your videos off, and there is going to be some time for questions at the end. And Sarah, kick it away. Thank you so much.
Thank you. Thanks to the organizers for having me today. This talk is kind of drawing from a lot of things that I've been working on for years, but it's really viewed, the information is viewed through the lens of how do we inform better decision making about the marine environment. And the area that I'm zeroing in on is ocean acidification, because that's a large area that I've been working on for the last decade or more. I'll talk a little bit about kind of the theory of vulnerability assessments first, and then I'll talk about some examples that I'm most familiar with that I've worked on. And then I'll talk a little bit about sort of what the takeaways are from that. So I'm happy to answer questions at the end. Just jot them down and we can dive in together. So risk is an integrated measure. The IPCC really defines it as the potential for adverse consequences for human or ecological systems. Climate risk can come from the impacts of climate change as well as the human responses to climate change, because risk really depends on that combination of vulnerability, hazard, and exposure. And hazard and exposure are a little bit more straightforward to think about than vulnerabilities. We'll start there. Hazard, as defined in the Special Report for Oceans and the Cryosphere, IPCC report, is briefly a natural or human-caused event that may cause harm to the things that humans value. And in that same report, they define exposure as the presence of people or assets in places that could be harmed. So that kind of makes sense. That kind of meshes with our intuitive sense of what these words mean, sort of colloquially. And then vulnerability is where it gets complicated. Vulnerability is the possibility of being adversely affected. And so vulnerability encompasses this variety of concepts and elements, including sensitivity to harm and the lack of capacity to cope and adapt. So you can see that vulnerability and risk involve at minimum multiple variables that have very different measurement systems. And these span different geographic and temporal scales. So the reason that I wanted to show you this and what we often call the propeller diagram, her highly technical name, is that this framework is really useful to think about how to assess climate risk and vulnerability. There's really no set protocol that we should follow to evaluate risk, because assessments depend on a wide variety of data as well as expert judgment of how these different parameters relate to each other. So there is some useful background reading, though, is this body of work that has come before. And if you want to go back to, the roots, you can look at the IPCC Special Report on Extreme Events that was published in 2012. And that helps us really think about how do we unpack and or assess and lower climate risk. So if we want to unpack this idea of climate risk, it kind of helps to consider what makes up the risk. So as I showed before, risk is the combined outcome of hazards, exposure, and vulnerability. So let's imagine this little scale as like the thing that you're measuring your risk on, you're weighing your risk. And so climate risk to a marine asset is often rooted in some kind of biophysical environmental hazard, like ocean acidification. But the vulnerability and exposure of human communities to that climate risk are rooted in the composition of and the choices made by human communities that depend on that marine resource. So decreasing risk involves decreasing hazards, vulnerabilities, or exposure. So on the scale on the right, we've kind of shrunk those components, and you can think of lowering your risk just by making those things smaller. But how do you actually decrease these? It's really, really site and system specific. So in the United States, when we think about ocean acidification risk to shellfish aquaculture in Alaska, your hazard is broadly ocean acidification, but the temporal and spatial characteristics of acidification really contribute to and fine-tune that hazard. And the vulnerability of Alaska communities to this depends on factors that are hard to classify as vulnerability or exposure. This can include things like how diverse are the aquaculture fisheries in the area, how many jobs depend on aquaculture compared to other sectors. And it's also really important when you're adding all this up to avoid double counting factors as part of the vulnerability exposure metrics. I'll show in a minute how that all played out in our Alaska vulnerability assessment. But there's another way to think about lowering risk that I want to point to now. So lowering risk and decreasing vulnerability can also involve increasing a community's adaptive capacity. And that can involve things like bolstering overall wealth, health, literacy, and job security. So if you assess risk comprehensively, you have to think about these positive factors that help offset vulnerability and exposure. And so in this metaphor, we're not shrinking hazard, exposure, and vulnerability, but we're offsetting their weight by using this sort of upward pull of greater adaptive capacity. And it's interesting to me that increasing adaptive capacity doesn't have to focus on marine factors at all, or the environmental issue at hand. So adaptive capacity really speaks to the social fabric of a community. I'll talk a little bit more about that in a second. When I mentioned hazard, I mentioned that there's temporal and spatial challenges. And so assessing risk really involves bringing together different kinds of data. And you have to pull them together in this quantitative fashion, but it can be almost impossible because you've got temporal and spatial differences between the information you're trying to assess. And sometimes those temporal and spatial differences make it impossible to actually bring together data in sort of a unified format. So hazard information, for example, we have for ocean acidification at a broad scale, but we know that microenvironments that are kind of zoomed down on in this schematic on the left of the slide really dictate influential conditions. And so at the same time, you have social systems at the very bottom of this schematic interacting with the whole, both influencing and being influenced by the climatic conditions. And then human behavior is another sort of really strong influence in the system, and other factors too. So in the first ocean acidification vulnerability study I worked on, we looked at ocean acidification risks to US shellfish harvests. And we made this big assumption that basin scale trends in acidification would also apply to local scale environments where the ocean acidification sensitive species are found. So that's kind of like the top two layers in this schematic. We have global climate model resolution acidification projections. We're pretending that we can actually zoom down and downscale these things into the regional and local environment. And we know that that's, you know, like a glossing over of detail, or, you know, because it's not a true downscaling. We're just kind of like thinking that broadly we think we know what the ocean conditions will be. But a lot of times the harvest data don't line up well with this sort of information. And any of these things can be really, really patchy. And sampling intervals vary, both for human variables like demographics, jobs, you know, wealth, income, as well as, you know, how often and how much shellfish are we harvesting. So we wind up kind of collapsing all of that data across all of those different layers that we're showing here. And we also know that lag times can also affect the data. It might take a couple of years for harvested species to recruit. Juveniles are going to be more susceptible to environmental changes, but by the time they recruit a couple of years later, they're subject to other factors like management rules, basin scale conditions, and a lot of other conditions can affect that social science data. Economic recession, state policies, even global seafood market factors can kind of, come in from the side and affect the way that this social ecological system is functioning. So it's all kind of a miracle when you can create one unified index. And what we found was in our US nationwide acidification risk assessment, the data really did not allow us to create any kind of an index. We had to satisfy ourselves with presenting the data kind of visually compiled, but we could not create some kind of an index that rolled it all together. And yet we still presented the information this way because we wanted to be honest about the shortcomings of the data and the fact that no, we do not have a really good mechanistic model connecting, river drainage as well as highly eutrophied areas, as well as high social vulnerability, as well as areas where our marine ecosystem is experiencing rapid acidification. And so what was really important to us to notice here was that the variables, are differing regionally, and you can see that. So you have water quality managers who are looking at sort of the purple and the yellow pieces, and you have folks who are thinking about sustaining coastal communities who are looking at the red variables. But then there's already a chance to crosstalk because we know that even if a resource manager is not directly focused on something like river discharges, it has to be in the mix of things they're thinking. And so this is even though we kind of had to present the data in this disparate way that was not rolled up together, it was still really useful for policymakers because we could demonstrate how, for example, here in the Gulf of Mexico, which is panel D, the water chemistry threshold wouldn't be reached for some time, but the social vulnerability and the influences from the coastal system were much stronger. And so that's important information for those resource managers to consider. Whereas in the Northeast of the United States, in panel B, excuse me, I couldn't hit the mute button fast enough. In panel B, you can see that the water quality or the ocean acidification threshold is going to be hit much sooner. And yet those communities have lower social vulnerability because they have greater diversity in things that sustain their communities. And these are the types of differences that we emphasized in the messages that we circulated with policymakers. So one advantage to presenting things adjacent to each other, but not kind of rolled up in one quantitative index, is it allows them to make their own judgments about the priorities and local needs. But it really doesn't allow people to identify the losers or winners in a particular situation. And that sort of calculus is often a goal for prioritizing allocation of resources or simply how to sequence community work that focuses on adaptation. So it does really speak, there is a real importance to trying to create risk indices where you can. So moving to the Alaska example that I touched on earlier, we took a more quantitative approach to look at a similar question. We wanted to do an ocean acidification risk assessment for the state of Alaska. And this is a logic model showing how we actually put together all of the different parameters for that study. And that study zoomed in on a smaller geographic area than the entire United States. So we had more data sets that were compatible with each other, both over that temporal and spatial characteristics that I mentioned before. A lot of times they were collected by the same or cooperating agencies. And so the data were not sort of overlapping or in conflict with each other in terms of what they measured. And so we could be more quantitative with this index. So we created this unitless risk index because we really wanted to look at the differences between communities across the state. And a key piece of the information we used was this subsistence harvest information from the Alaska Department of Fish and Game. In Alaska and elsewhere in the United States, recreational and non-commercial harvests of marine species are really poorly cataloged. In Alaska, it's very well cataloged because it's a really important piece of how indigenous communities and local communities in Alaska sustain themselves. And so it really contributed to our ability to drill in on what acidification could mean for people living in Alaska. And so we used the variables related to economic and nutritional dependence in a couple of ways, and it spoke to both the importance of the species challenged by acidification, and then also the quantity of these species being harvested. We also looked at variables related to adaptive capacity. So remember, those are the things that relate to community vulnerability that have nothing to do with the marine environment. So things that would increase overall health, wealth, education, and those are things that lift the community broadly. The sort of explanation of this logic model is more complicated than I can fit in here now, but I do encourage you to take a peek at that paper because we spent a lot of effort trying to explain this whole mess clearly. So this is what it wound up looking like. In this study, we did create a single index that rolled up all those hazard, exposure, and vulnerability factors into a single number. And we also were able to present the data with the different layers at the same time. So the yellow, blue, and red colors indicate those final index values, whereas like the population, commercial harvest values, subsistence fishing levels could also be shown. And so that helped us not only zero in on the factors that allowed burrows to differ from each other, we could also present sort of a unified, almost look that helped decision makers in Alaska prioritize among communities that had different risk factors that ultimately wound up placing them ahead or behind others in terms of their vulnerability to acidification. And so we did find that the adaptive capacity varied very widely among burrows in Alaska. And this was on top of the regional variations in economic and nutritional importance of shellfish, and in addition to differences in economic and nutritional dependence on these species. And so in some ways, you can argue that when you drill into these details, sometimes when you find that adaptive capacity differs widely among communities with different socioeconomic conditions, it's kind of not that surprising. But the benefit of having these sorts of quantitative information is that a lot of times it fits in better into the decision-making metrics that decision makers are using. If you go to a leader and you say, this burrow is in worse shape than this burrow, they are, because of thus and such reasons, it's a little bit easier to comprehend than and zero in on fixes rather than kind of coming in with that traditional narrative of like, marginalized communities are doing more poorly because decision makers say, well, where do I begin? I know that, but where do I begin? So this allowed us to really drill in a little bit more on specificity. So in another paper with some colleagues from Dalhousie, we also used a similar approach to look at the combined risk from acidification and climate to fisheries in Atlantic Canada. And in the way that we group things, we included New Brunswick, Newfoundland and Labrador, Nova Scotia, Prince Edward Island, and Quebec. So in this study, we created an index to compare among the provinces, but it was a lot more detailed regarding the natural science and fishery data by virtue of the ocean model that we used. We used a dynamic bioclimatic envelope model, and that allowed us to get a lot more specific about what ocean conditions were likely to be and how they were going to play out for the harvested species in those areas. We did have less detail on the social science data, and also we were less able to project what future environmental conditions could do to the social cultural system in the area. But what was new about this study is that we looked at a new region with a little bit more sort of downscale detail And we also looked at what expected temperature increases would do, because we know that that's going to be a giant factor in terms of how Canada experiences changes. And so again, here we considered adaptive capacity to be that factor that kind of lifts vulnerability. It counters the effects of sensitivity, which is what we constructed as dependence on shellfish for jobs and income. So this biophysical model showed us that acidification-driven declines in the region were going to be minor compared to the temperature-driven changes in future landings. And I think that's really useful to know, because even though there's a lot of suspicion that acidification could really affect pre-recruits for a lot of fisheries, the temperature signal is so strong in this area that is really the thing to plan for. And what we saw were the expected or notable redistributions under acidification and climate change in the next century. And so it's kind of tempting to think about the winners that receive the shifting fisheries as gaining access to new production. But in the paper, Tyler, the first author and the master's student leading this work, really made the point that it's so important to recall that these increases in one area come at a cost to other regions. And although acidification effects could be overwhelmed by temperature-driven increases, this should be kind of contextualized as like it limits potential gains and it worsens declines, rather than like, acidification's no problem, we're just worried about temperature. It's definitely a co-occurring driver situation where you are limiting gains by having both warming in northerly areas and acidification. So in short, New Brunswick and Nova Scotia are expected to see declines in the resource accessibility, but they're pretty socially insulated from those changes. But Prince Edward Island and Newfoundland and Labrador are more socially vulnerable to the losses in fisheries, but they'll experience relatively minor net changes in access. One thing that that we kind of wish to do in a future study would be to, we felt good about how we could zero in on the more fine scale changes in the water. But we know that it doesn't necessarily reflect the benthic environment where these species live, or the very near shore environment where these species live, and there's going to be changes in the prey that they're eating, as well as who is preying on them. And I don't think that we got as fine scale resolution as we would have liked on that, and I think that could be an area to work in the future. But I think what also would be nice would be to dig more into the social science side of things here and really look at how well equipped the areas that are receiving fisheries are to sustainably harvest and manage those fisheries, and to look at whether there's governance obstacles that need to be resolved to help receive the benefits that, of new fisheries moving into the space, whereas while not compromising the integrity of that stock. So overall, just a few words on how we think of these studies as informing decision making. So even when the analyses don't roll up nicely into a tidy summary, they can be really useful for decision makers. On this slide is an example of the two-pagers that we created for policymakers to talk about that original coast-to-coast United States shellfish vulnerability analysis. We were able to show the data, adjacent to each other, but again, not rolled up in an index. But it really allowed us to share with policymakers how regional differences and regional tendencies affected the landscape of the decisions that had to be made. So each of the regionally focused fact sheets, which you can see a snippet of on the right, explained the regional characteristics that heighten local risk to shellfish industries from ocean acidification. And presenting that data as the map layers allowed policymakers to compare contrast and say, well, okay, if I'm representing New Jersey, what does that look like compared to Washington State or Florida? And that has really allowed decision makers to think about local concerns and possible solutions that are very like specific and appropriate to the area. And so that study was, almost 5-10 years on. I mean, it's been a while since that study came out. And by now we are seeing really much greater investments in the Gulf of Mexico area to examine those confounding factors like harmful algal blooms, because that's a local priority and it fits into the long tradition they have of water quality monitoring. And it's speaking to what's relevant not only for that community, but also what's relevant for the broader picture of acidification vulnerability. But it also is honest in recognizing that that area is not the first in line to see substantial changes in ocean carbonate chemistry conditions, like you would see in the Pacific Northwest or New England. So these studies also really offer, kind of to sum it all up, right? They offer decision relevant information that really spans a number of systems. And granted, we know that a lot of times resource managers are focused more on the natural system or more on the human system, but everyone is increasingly aware that these systems interact with each other pretty substantially. These studies are also really helpful for identifying priorities for research and investments. The studies can identify knowledge gaps, showing us where we had to make inferences to kind of make the analysis go forward. And these studies can help us have informed conversations between the scientific community and the decision-making community about how to close those knowledge gaps. And then these studies are also shedding light on what sorts of policies or obstacles can address local risk, and what sorts of obstacles exist between preparing communities and today. So, for example, when I was talking about the Alaska instance, we could identify a few places where social factors had been eroded over the last several decades. Communities were more poor, they were less healthy, they had young people that were leaving, and those speak to a certain set of policies that can be enacted to support those communities in the face of the change that they're going to see. Whereas, in the Pacific Northwest, an early monitoring system in the water is the most useful thing to address risk from acidification. So just a few final thoughts to think about how these studies really fit into the context of what can we share, how certain can we be. We know from not only this sort of work, but also just from social science work for a long time, that strategies to mitigate and adapt to acidification and climate impacts have to be prepared by the communities themselves in partnership with leaders. We need community information to know that communities are experiencing more challenges from, for example, lack of job diversity rather than infusion of money into higher education or something like that. We also know that co-production of knowledge is so important to develop trust and also investment in finding a solution together. We also know that factors that lower adaptive capacity, those balloons that I've talked about, it's a key piece of adaptation. And when we're talking about ocean adaptation, it's important for those of us who are very, focused on the ocean world to remember that adaptation is oftentimes not ocean focused, and that's fine. That's actually important to keep in mind. So it speaks to our need to continue building bridges from the sort of ocean and natural science world into the social science and community development world. And then finally, I think we want to think about revised policies to be like multi-tools. They should do a number of things at once to reduce risks. They need to build adaptive capacity, decrease exposure, decrease vulnerability, and focus on increasing equity and justice instead of leaning on established pathways that depend on the engagement of powerful or privileged actors. So I really think that the vulnerability studies kind of shed a light on just how multivariate these systems are and how the solutions have to be as well. So I'll stop there, and I'll be happy to answer some questions now if anybody has any. Let me see if I can stop sharing without wrecking everything.